A redox titration is a titration in which the analyte as well as the titrant react via an oxidation-reduction reaction. In this experiment, we will be using a redox titration to determine the percentage of hydrogen peroxide in a commercially sold hydrogen peroxide solution. We will also be determining the percentage of iron in an unknown iron salt. This experiment comprises of 3 parts. Firstly, the preparation of the standard potassium permanganate solution, which will be used as the titrant. And secondly, the titration of the commercial hydrogen peroxide solution. And lastly, the titration of the unknown iron salt. In this part of the experiment, a standard of 0.1 molar potassium permanganate solution will be prepared in a 250 ml volumetric flask. A standard solution is a solution of accurately known concentration that is prepared by dissolving an accurately weighed compound in a fixed volume. To prepare this solution, you will need to calculate how much of the potassium permanganate you should weigh in order to obtain a 0.1 molar solution in a 250 ml. The potassium permanganate is weighed using an analytical balance. This is done by firstly placing an empty 100 ml beaker into the mass balance and setting the balance to 0. The mass of the potassium permanganate required is then added into this beaker, and this mass is recorded to 4 decimal places. In this experiment, we are preparing the standard potassium permanganate solution of 0.1 molar concentration. And to do this, we have already accurately weighed our potassium permanganate into the 100 ml beaker. We are going to quantitatively transfer it into our 250 ml volumetric flask. Firstly, we put our funnel in here, and then we use deionized water to dissolve our solid. Then we slowly transfer it into our volumetric flask. We are going to rinse the beaker multiple times with about 10 ml of the deionized water until everything is completely dissolved. Once this is done, we will measure 30 ml of the 3 molar sulfuric acid using a measuring cylinder. Thereafter, we will add this sulfuric acid into our volumetric flask to make sure that our standard solution is an acidic media. From there, we will gently swirl the bottom of the volumetric flask to make sure that our solution dissolves. Then now, we are going to fill up the volumetric flask with our deionized water up to the graduation mark of the flask. Once we are getting closer to the graduation mark, we will then use a plastic dropper to add the deionized water. Remember, the meniscus of this solution should lie at the bottom of the graduation mark. From now, we will close this volumetric flask with a stopper and then gently mix it upside down to ensure that all the potassium permanganate is dissolved. Now we have our standard solution prepared. Here we have our 50 ml burette that we have already rinsed with deionized water. Now we are going to rinse the burette with 5 ml of our standard solution. Firstly, you need to make sure that the tap is closed. And then you place a funnel, transfer the standard solution into a beaker, and now you can add about 5 ml. From this, we are gently going to swirl the solution down the sides of the burette. And this you can do 2 to 3 times. Now we will discard our standard solution into the waste beaker to make sure that we clean the tap of the burette. If there are any spillages, you make sure to wipe them. After rinsing the burette, we now fill the burette with the solution. Now we fill the burette and clamp it. We need to make sure that our solution is filled into the tap, and now we're going to close it. To ensure that there are no bubbles into the solution, we are going to twist our tap 180 degrees very quickly. And now the tap is completely filled with no bubbles present. Once we have our solution in here, we can read the volume of the burette to 2 decimal places. And to do this, we are going to need a white piece of paper at the back and make sure that the burette is clamped to our eye level. Then you record your reading. You can repeat this titration at least twice or 3 times for a total of 3 titrant volumes. In this part of the experiment, we are transferring our commercial hydrogen peroxide solution into the 250 ml conical flask. To do this, we are using a 10 ml pipette to transfer all the solution that is required for the titration. Now we are sucking up the solution using the pipette, and we are going to ensure that it fits into the graduation mark. Now we can transfer our solution by releasing it. Now we wait for 15 seconds to ensure that the last drop of the solution is added into the flask. Once this is done, We are now going to dilute our hydrogen peroxide with 75 ml of deionized water. And lastly, add our 20 ml of the 3 molar sulfuric acid. Now our hydrogen peroxide is in an acidic medium and the redox reaction can take place. We will begin titration by placing our conical flask on a white sheet of paper, making sure that our burette is clamped for us to perform our titration. We will be using our left hand to hold onto the tap and control it. Then we will use our right hand to swirl the conical flask during the titration. Firstly, you need to take the initial reading and record it. Once that is done, you can begin the titration. This is a rough titration where we open the tap and hope to observe an equivalence point with a color change. Our potassium permanganate is an oxidizing agent that reacts with the hydrogen peroxide. For as long as this reaction is taking place, there will be a discoloration of the purple permanganate solution. When we have reached our endpoint, this will be seen by a persistent color change While you're performing your titration, you will need to rinse down some of the droplets from your titrant to make sure that everything in the flask is well mixed. Then we continue adding our titrant slowly into the flask. When you are closer to the end point, you will have to add this titrant dropwise into the solution. Now we have to rinse. And continue titrating. The faint pink color is now persisting for longer than 30 seconds, then this means that we have reached our end point. Once you are done with your titration, you need to take the final reading of the volume. From this, you put a white background and carefully read the burette to 2 decimal places and record. From this, you will determine how much volume of the titrant was added into the conical flask to completely react with your hydrogen peroxide. It is not necessary to fill in the burette up to the 0 ml mark for each titration. Be careful not to start above the 0 ml mark or titrate past the 50 ml mark. In this part of the experiment, we will be using the 0.1 molar potassium permanganate standard solution to determine the percentage of iron in an unknown iron salt. In this part of the experiment, we have already accurately weighed our 10 grams of the unknown iron salt. From this, we have quantitatively transferred it into our 100 ml volumetric flask and dissolved it with deionized water as well as 20 ml of the 3 molar sulfuric acid. The solution was filled up to the mark using deionized water, similar to the preparation of the standard permanganate solution. Now, we have transferred this solution into the beaker to ensure ease of delivery to the conical flask using a pipette. From there, 10 ml of this solution was transferred into the conical flask, and we are about to add 10 ml of sulfuric acid. Here we gently swirl the conical flask with our content, and we put it underneath the burette for titration. Similar to the previous titration, we will use our left hand to control the tap and then use our right hand to swirl the flask. While ensuring that the initial reading has already been taken, you can begin to titrate your solution. With this solution, you will have to be careful while adding your potassium permanganate standard solution into the flask. This is to ensure that you do not overshoot your end point, as this is the first rough titration that is done in this experiment. Now we have reached our end point. You need to also remember to wash down all the contents into the flask if they are still stuck on the sides of the conical flask. This brings us to the conclusion of our redox titration experiment.